In this ACT video, we're going to take a look at solving systems of linear equations. A system of linear equations is simply more than one equation with more than one unknown. In this video, we're going to look at systems of just two equations with two unknowns. So for example, I have here x minus y is equal to 1 and 2x plus 3y is equal to 12. I've gone ahead and graphed both of these for you. Graphing a system is one method for solving, but it's not the most efficient, so we're not going to focus on that in this video. But just to give you a picture of what's happening, that green line is my equation x minus y is equal to 1, and the purple line is my equation 2x plus 3y is equal to 12. What we're doing is we're looking to find where these two lines intersect, and we can see that they intersect at the point 3, 2. That's the point that they have in common. Therefore, that's the solution to our system. Most of our solutions will be ordered pairs, okay? And this is pretty easy to check if you plug it into the original. 3 is your x coordinate, 2 is your y coordinate, so that gives me 3 minus 2 is equal to 1. 3 minus 2 is 1, so that balances. We're good to go there. And plug it into the second, we've got 2 times 3 plus 3 times 2 is equal to 12. And that gives me 6 plus 6 is equal to 12, and 6 plus 6 is 12. So that balances as well. So it's pretty easy to see if you get them right or wrong. A second scenario we may see are parallel lines. And both of these lines, you can tell, have a slope of 1, rise 1, run 1, up 1, right 1, slope of 1, and a slope of 1, so we know they're parallel. So they will never intersect. And if the whole purpose is to find out where the two lines intersect, and these two lines don't, then we would say there is no solution. There is no solution in that case. And a third scenario we might see, I've got an orange line graphed and a blue line, and I have them slightly offset just so you can see that there are two lines there, but those two lines are the exact same lines. Therefore, the blue line and the orange line will intersect at every single point, and the answer there would be infinitely many solutions. Infinitely many solutions. These two lines have infinitely many solutions because they cross at every single point because they're the same line. Now, like I said, graphing is not the most efficient way for doing this. In this video, we're going to take a look at something called the substitution method. The substitution method takes one equation and substitutes it in for the other. Here we have x plus 3y is equal to negative 7 and 4x plus 3y is equal to negative 1. Neither one of these equations say x is equal to or y is equal to. That's what we need to get to. So I'm going to have to solve either the first one or the second one for either x or y. I choose to solve the first one for x because it's just about by itself. It is a 1x, so all I have to do is move the 3y over. So let's go to the margin, and let's take x plus 3y equals negative 7. And we need to just take our 3y, move it to the other side. When we do that, its sign changes. This gives me x is equal to negative 3y minus 7. Put that in parentheses, then we're going to take that quantity and substitute it in for x in the other equation. Hence the name substitution method. So my second equation, we're going to remove the x. This now becomes 4 times something plus 3y is equal to negative 1. Again, we took out the x, and now we're going to substitute in what x is equal to, and that's negative 3y minus 7. You're done. You're at least done substituting. Now we have to solve. So we need to distribute. This gives me negative 12y minus 28 plus 3y equals negative 1. We're going to combine our like terms. So we've got negative 12y plus 3y is negative 9y minus 28 equals negative 1. Simply add 28 to both sides. 28's cancel. Negative 9y is equal to 27. Divide by negative 9 on both sides, and we get y is equal to negative 3. Well, that's half our answer because our answer should be an ordered pair consisting of an x-coordinate and a y-coordinate, and we've got the y-coordinate. We could take that negative 3 and substitute it into the first equation, the second equation, or over here, this manipulated equation. I recommend substituting it in the manipulated equation because you're going to get your x answer so much faster. And remember, the ACT is timed, so we want to make sure we are working efficiently. So we're going to take our y is equal to negative 3. Let's move it up here and substitute it right there. That gives me x is equal to negative 3 times negative 3, because that's what y is, minus 7. That gives me negative 3 times negative 3 is 9, minus 7, so x is equal to 2. Final answer, ordered pair 2, negative 3. So with the substitution method, you want to take one of your equations, solve it for x or y, plug it into the other one, solve that equation, substitute again. In the next video, we'll look at the elimination method.